Good afternoon, everyone. My name is Darren Kao. I am in charge of the R&D department in Brightek, a company located in Taiwan. Get to know Brightek. A company has been innovating since 2001 with strong focus on the automotive LED components. We excel in color mastery and light solutions. Especially, we are good at integrating semiconductor driver IC and with the photonic chips. So we also offer a range of optical sensors and the ICLED product for the market. Entering the topic today, I would like to introduce the ICLED technology first. The ICLED technology is a system-in-package technology. Okay, we integrate a driver semiconductor IC with a series of RGB LED dies. So it can be easily to communicate. You just need to directly send a signal to the ICLED. Then you can control the brightness and the colors. Here is the first advantage of the ICLED. This is standard RGB LED mixed color distribution, okay, with 100% fully on the RGB dies. You can see that the whole distribution over the CIE range is quite large, over than the 3 megahertz ellipse area, which is the black ellipse curve. That makes the color distribution, also the feeling about the color, very easily to feel the difference if you put the LED very closely. To integrate the IC, that problem will be solved because we can adjust and calibrate the RGB LED brightness every channel. So it makes the concentration of the light distribution. So compared to the RGB LED, you can see that the color consistency can be greatly improved. The second advantage of the ICLED is about space. Here comes an example about a dual color modules. So you see a line modules, you need a big module for the driver board. So the green board is the external one, and then you need many wires to connecting to the LED PCB board. Especially, you need a big space for the copper trace on the PCB board to link the wires to the LEDs. So it's making your design bulky and complicated. But if coming facing into the ICLED, then you need a compact control board. Especially, you need only very slim LED modules. Okay, so it can save you a lot of space. In the electrical circuit point of view, you can save 30% space if you face in ICLED. Space is cost. Some people will ask us about, is this just an idea for the automotive? Actually, we already shipping out many ICLED to our customers for automotive ambient lighting from 2019. So already 6 years we running this kind of technology. There were many car models with the ICLED technology inside. More and more car models is ongoing. So that proves the ICLED is not just an idea. We keep investigating better and also economic and also efficient control model. First, we just integrate the driver and the LED to become ICLED. Then we also calibrate that, so you don't need to calibrate the LED on the module anymore. So you don't need to save or keep the data about the color calibration in the MCU. So the second step, we're trying to potentially remove the MCU. That makes the ECU, between ECU and the ICLED, you only need a transceiver in between. So we define a new smarter transceiver named the ETR. Okay. The ETR is addressable. The addressable is we can support like using one SPI port to control 32 line modules. So it can enlarge your control. And we also using the SPI and the I2C and the bridging by the CAN-FD, which is quite standard protocol for automotive. We also build in a lookup table for temperature compensation. And we also allow you to use such kind of CAN-FD to transmit 10 meter long. It's also with the broadcast function, which can better use for you to efficiently control. And also the high temperature, operation temperature range, like -40 to 125 degrees, which is quite suitable for the automotive application. Okay, here comes your idea. So if we further use the ETR, what happened? It will give you 10% more space reduction. So compared to the conventional model, you can save 40% space. So it's quite safe, even more than only ICLED space for you. So the cost can be even lower. And it also can, to compensate the temperature effect locally. So it can also communicate with the sensor and the ICLED together. But we can build in the lookup table. So you can use based on the lookup table to control and compensate, do it all. Here can give you some scenarios. The first scenario is like this. The ETR can locally compensate all the line modules individually. So at the same time, you can do that. You don't need to one by one to check line modules temperature and do the compensation. You can do it at the same time. So it can speed up the efficiency for you to control. And the second scenario is like this. ETR can control 2 line modules by 1 slave only. So it can also make you to use it more better to compare to the conventional one. Here is a conventional one. 2 modules, then you can become only 1 communication line to using ETR. We talk in the third scenario is sensor and the LED integration. Now the ETR can using only 1 communication signal line to link with sensor and the ICLED. So you can control the ICLED and the sensors at the same time. Compared to the conventional one, you can save a lot of electronics and also save wires. Here I make summary about the ETR performance for you. The ETR can transmit up to 10 meter long and 5 megabits per second high speed, and also lower 30% cost. Especially, it can enlarge the controlled line module quantity via only 1 MCU. So it can also save your MCU cost a lot. So the ETR and the ICLED can support you to do the central control concept for automotive. It's only require the ECU to control all the line modules. You don't need any separate MCU to do that. Now you can purchase the software upgrade over the air, like autopilot and also the infotainment system. In the coming future, you can do this for upgrading your light effect in the future. Here comes the summary. We have the ICLED product portfolio like this. We have side view and also top view, EVO, ECO, smart LED, ICLED, with market-leading brightness performance. And we also offer the smart transceiver for you to use the ICLED easily. Thank you for your listening, and arigato gozaimashita.